merge AI technology specialists with infrastructure specialists in order to create true innovation that works in real life.
I'm going to talk to you about SiteSee and particularly what we do in AI. So first I'll just talk about the problem space and the industry that we're trying to solve. So we look at assets like these. There's millions of these sort of assets around the world that are costing their owners billions of dollars in unnecessary inspection and maintenance upgrades. SiteSee solves this problem by merging reality modeling and AI to allow infrastructure owners to fully understand what's on their asset, to allow them to make more informed decisions on how to manage their assets. And this is SiteSee. So we start off by capturing the customer's asset as a reality model and visualizing it on our cloud-hosted platform. And sure, it looks great, pretty, you can spin it around, but that's just the start of what SiteSee does. This is where we really get our AI in. So we do automatic object recognition of equipment for cell towers. So we can identify pieces of equipment on this tower automatically. And when we mean that, we mean all the dimensional characteristics of those RRUs on that tower. You know, ground from height, width, varying tilt. But we can also have different classifications or identify different types of equipment. So we can also identify dishes and also obviously the panels. And we do all this fully automatically using AI.
So enter the Movus food machine. And I've got a couple here that I can start to circulate around. Maybe you could Lucio start those off. People can take a bit of a look at them, have a feel and see how the device operates. Essentially, it's a sensor, self-contained sensor. It's a sealed unit with a very powerful magnet on the back of it. This is using an exotic metal whose name I've forgotten. And this attaches it very strongly to the surface of the machine. And with the sensor, we pick up acoustic and vibrational and temperature information and other things. All that information we can then use to try and do exactly the diagnostics that I've been talking about. So it attaches anywhere on the machine, and there's a bit of a process deciding where best to attach it, and then all this information comes through. What we offer as a business is a complete service. So it's not just the sensors and the AI, we're technically really a SaaS company. We allow the sensors to be installed, we put in gateways where they're necessary, we bring the information back to our AWS servers. That goes through our AI, it does some training and inference and so forth, and then some analysis, and that will produce some diagnostics on hazard conditions when they arrive.
So we actually develop ground-penetrating radar. We design it here, we develop it here, we build it here. It's Queensland technology. No? Doors? Yeah. It's good stuff. The areas in which we operate, okay, for infrastructure is pavement, it's the roads, it's the airports, it's looking at the growth of those as well. So we're not just looking at construction in that space, but also the maintenance. And the other key area, of course, is utilities. Now utilities, as you can see some of these statistics here, I'm sorry, I haven't got Australian statistics, very hard to get a hold of, but UK, 60,000 accidental strikes on utilities every year. Okay, £260 million in repair, but nothing compared to the cost of the legal, which is 6.5 billion. So what we're looking at EarthRadar is first things first, how do we capture it, okay? So we invented the radar. We invented a patented noise modulated radar, which operates in 3D. So that means as it's going along, it's scanning multiple sensors at a rate, and it's picking that up in 3D. It also picks up surface imagery with a LiDAR, and we use that for positioning as well. Service positioning, and then the camera for service imagery.
So, as Alex said, I'm Seun, and I'm working at UQ, doing my research out there. A lot of my work is on intelligent predictive maintenance. So, think about any asset, your machines, mining machines, your bridges even, looking at how to characterize all those assets in terms of data and how to present that into an AI algorithm and develop something for it specifically to present results and knowledge to the domain experts. So, exactly, predictive maintenance. So the idea here is we're looking at just about any asset, any machine, and how to make sure that the data-driven predictive analytics for it is actually intelligent. So no longer doing engineering metrics, and bringing methods of machine learning. But that brings a challenge. I think that's something that everyone here has a question about. How do you actually integrate machine learning into your everyday work in an industrial setting? There are two things that you really have to consider. Is what does your data look like to a machine learning algorithm? And how do you structure your data to be used properly in machine learning? And the second is, what are you actually trying to get out of applying a machine learning algorithm? What information are you looking to get from using all this AI magic? Not really magic, there's actually math to it, but it starts to look like magic after a while.
Alright, so I'd like to get 3 responses from the audience for those who are feeling brave. What is the difference between machine learning and artificial intelligence? Do you think there is one?
I think machine learning is just an application of artificial intelligence. Artificial intelligence in itself is a very big field, and machine learning is just a part of it.
Okay, so we've got machine learning as a subcategory of AI. Anyone else? We've got 2 more.
I actually slightly disagree. Humbly, because I have no expertise whatsoever in the space. But I would have said that artificial intelligence is exactly what it's called. It's just the appearance of intelligence without any sentience behind it. Whereas machine learning is a means to achieve a form of artificial intelligence. So if I play Age of Empires that I got in a CD in my Nutrigram packet when I was a kid, the computer appears to have intelligence despite never having had any machine learning applied to it or experienced by it.
So
it can experience
AI
something. Oh my god, I'm spiraling!
the facsimile of human problem-solving abilities.
That's a much better way of putting it, yes.
Okay, one more. Let's do well-suited gentlemen at the back.
So, machine learning is a statistical approach to a bunch of optimization problems, and I would call it an approach towards artificial intelligence. It's an approach which has done pretty well lately. Made progress on a lot of old problems, that's great, but there's a load of other approaches to AI that are not machine learning, and conflating the two terms like some people do in industry, or calling it cognitive like IBM Watson like to do, is, at best kind of harmless marketing, and at worst is pretty misleading, and could lead to maybe another AI winter if people overinvest in machine learning and don't consider other approaches as well.
Okay, a jargonized approach that also appears to be a subcategory of AI.
And I think a big round of applause for Alex.